test. Sorry, I was just about to say testing because I always test the volume on these videos. Oh well, it's early morning. Here we go. In this lesson, you will be learning how to find the volume of spheres and hemisphere, okay? The key concept, obviously, is how do you find a volume of a sphere and a hemisphere? You can think of a sphere like a basketball. That's kind of the easiest example to use. The symbol is volume equals 4/3 times pi r cubed. Okay, so similar to the volume of the cone where it was 1/3, but we're using 4/3 now. Okay, so it's actually a pretty easy formula. I'll kind of walk you through it. So you want to always write out what you're doing. So 4/3 times pi, you can use 3.14 or the pi sign on your calculator, whatever you prefer, times the radius, which is 8 in this case, cubed. Okay, so let's do 8 cubed first. Get out the calculator. 8 cubed. All right, here we go. 8 cubed is 512. So 512 times 3.14 times 4/3. Now 4/3 gets a little messy because it's really like 1 1/3, and as a decimal that's 1.3 repeating, and you don't really want to get into using that decimal, so it's better to multiply first, like multiply this whole top row and then divide by 3. Okay, that's my recommendation. So let's see that. 512 times, I'll use the pi sign, pi times 4 equals that, divided by 3 equals 2,144, and we'll round to the nearest tenth, 2144.7. 2144.7. And that's what we're going to use. All right, let's go ahead and go to another example. And let's do the basketball over here. We've got, it looks like basketball. And let me just pull up one other thing. All right, so we're going to go ahead and write our formula again. 4/3 times pi times 7 feet. Oh, I forgot to write my inches cubed. 7 to the 3rd power. Okay. So let's go ahead and do that. 7 cubed first. 7 cubed is 343 times pi times 4 equals that, divided by 3 equals 1436.8. 1436.8 feet cubed. Okay, so that was 343 times pi times 4, all divided by 3. Those are your answers. Let's highlight those just so you have them. And let's go on to the next page. Okay, then first one is a U try for you. You've got your radius listed very nicely. Use your formula. Then you've got a sphere with a radius of 10 feet. Both of those should be no problem. Okay, let's do a word problem. A spherical stone in the courtyard of the National Museum of Costa Rica has a diameter of 8 feet. Find the volume of the spherical stone. Okay, it's written out right here, but I'm going to go ahead and do it for you. First of all, remember diameter. We need to cut that in half to get the radius. So our volume is 4/3 pi times radius, which will be 4 cubed. Okay, 4 cubed is 64. So 64 pi times 4, all divided by 3. So 64 times 4 times pi equals that, divided by 3. 268.1 if we round to the nearest tenth. And it's, looks like it is feet cubed. Okay, I want you to try this one. This is you try number 3. A dish contains a spherical scoop of ice cream with a radius of 1.2. Let me just write that out for you so it's a little neater, it's a little blurry. What is the volume of the ice cream? And that's inches, okay? And then move on, we have an example 4. This time we have a volleyball. It has a diameter of 10 inches. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball? Okay, so we need to take this, and let me just get my book example up so I have it ready to go so I can work from that. Okay, so our volume equals, I believe this time you have the volume, so let's just go here. Sorry, my screen recorder is having a little bit of trouble here. Give me 1 second and I will get it back going. Okay, so we're going to go ahead and calculate the volume. So 4/3 times pi times 5 cubed, because diameter of 5 or 10 means radius of 5. And so we will calculate that out. 5 cubed is 125 times pi times 4 equals that, divided by 3 equals 523.6. Okay, so it's 523.6. Okay, and that's cubic inches, so that's our volume. Now we have to do a proportion to kind of figure out how many minutes it will take to inflate the ball. Okay, so we would take 325 is what they tell us it takes to do 1 minute. 1 minute. Okay, wait, 325. Let me fix something here. It's 325 inches. Okay. We want to know with our volume of the ball, okay? So a pump can inflate the ball at a rate of 325 cubic inches per minute. So if our volume is 523.6, how long will it take to inflate ours? So we would set up a proportion, okay, and we would just do 325x equals 523.6, and then divide 523.6 divided by, what was the other number? 325, and it will get 1.6. So it would take 1.6 minutes to inflate the ball. Okay, so that one's just a little bit trickier. This is asking us to apply our volume to how long it might take to pump something up. So you have a similar question here. Okay, so you have a diameter of 6 on your snowball. It's a 6. How long would it take the snowball to melt if it melts at a rate of 1.8 cubic centimeters per minute? So calculate your volume like we did with the volleyball, and then once you get your volume, convert it with the proportion 1.8 centimeters per 1 minute. Put your X value here, and then this is going to be your volume, and then you'll solve for that. Okay, last thing is hemispheres. Okay, a hemisphere is basically half of a sphere, okay? So a circle separates a sphere into 2 congruent halves, each called a hemisphere. So to find the volume of a hemisphere, it's very simple. You find the volume of the sphere and divide it by 2 or multiply by 1/2. So if we have a hemisphere with a radius of 5 centimeters, let's calculate. Volume equals 4/3 times pi times the radius cubed, which is 5 cubed. So we're going to go ahead and multiply that out. That would be 125, because that's 5 cubed, times pi times 4 equals that, divided by 3 equals that, and then you take that and divide that by 2. And you will get 261.8. Okay, so you end up getting, let me just calculate it back for you. It was 523.6 was our volume, 523.6, and then if we take that and times it by 1/2, that gives us our hemisphere. Okay, you try number 5 and 6. You've got this is, I believe, the radius on F, and I believe E, let me just check here real quick. It looks kind of like a diameter, but then it also looks kind of like a radius. So I'm going to say, let's calculate this as I say this is, it looks like a radius to me, so that's a radius of 2. We'll use that, okay, because that's hard to tell based on the picture. All right, if you have any questions, please don't hesitate to ask, and that's about it. Bye for now.